All right, everybody. So we've been talking at the switch level and how you can build a network over switches. And that does a decent job until you kind of have multiple ISPs interacting over a giant network. And then suddenly you need a way beyond just MAC addresses to communicate between devices. And that's when kind of the next layer, the network layer, comes in. What that next layer is going to give you is the ability to drop messages kind of into your network. It will forward that message according to its destination IP address to wherever it's supposed to go, and then that will reach that destination IP address. So if you drop a different IP address in there, it might go off into the network and find a different IP address based on this destination IP address that you drop along with your information. And that happens at the network layer. In order to actually get this thing to interact with a specific program that's sitting on your network, you also need to describe the transport layer and what port where that item wants to go on that remote service. So when I drop this packet off for a destination IP address, it might reach this remote machine, but the port number at the transport layer tells it which service to go to. So IP address plus port, this destination IP and port, is going to tell me both, hey, this machine and maybe this service. So when I go to my web browser and I type in google.com, the first thing that happens is I do a DNS lookup and I find the IP address of google.com. And then what my browser will do is it will pick a random port for myself. And so it will drop my IP address in this random port for me to listen to into this network. It will go through the network, find that IP address that we looked up for google.com. The port number that it will use is port 80 because that's default for HTTP. And then it will do whatever you requested. So if you dropped a get slash index.html with HTTP 1.1 with host google.com, then Google will look at this message that you're sending and it will say, oh, I know what to do. I want to give you the index.html page. And then in the packet that you dropped off, you had to specify the destination IP and port so that the network knew where to deliver that. But you also listed your own IP and that special port that you got from the OS. And so this server will say, hey, I know exactly where to send my response. I'm going to send my response to whatever was in that packet. That now becomes the destination IP and port. And I'll send it through the internet back to you. And so in this way, I can send off a message. It goes to the right place. It goes to the right service at that place. And then it can respond to me. So if I have a bunch of tabs here, those tabs will all get different random ports from the OS that are unused. And I can send off these packets. Maybe they even go to different IP port numbers. I might even go to the same IP and port more than once, right? Like you go to google.com and you search for, why is Voldemort stealing my shampoo? And then you go to google.com and you say, hey, tell me more about kittens or whatever, right? Like show me funny kitten videos. It's also possible with this approach for a service to have more than kind of one service on it. So not only can I connect to port 80 from my browser a bunch of times, but I might also use a different program to communicate with a different service sitting on the same location, right? So this IP port pair is what is needed for process to process communication. It is how your program communicates with another program. It is how your web browser communicates with a web server. It's how google.com tells you what its index.html page looks like. It is how you make connections. You need in this packet that you're sending out across the internet, you need both source and destination IP. And as you might have guessed, there are checksums. There's a length of the payload that needs to go in here, and some other things which we will get more specific about. But for now, I wanted to kind of give you a sense of why, when you're operating at the application layer, do we care both about IP address and port so much, right? We need both of those in order for program to program communication. The IP address, the network layer, only gives us machine to machine communication. And when your network card gets some message for some port number and some IP address, it will then kind of query the OS and say, hey, is anybody actually listening for this? And assuming that there is, it will forward that information off to the correct place. And it does this via sockets, and sockets are kind of the mechanism for kind of binding this IP port to either a service that's listening, or to a socket that you've created to connect to some service, in this way. All right. Well, I wanted to keep this short and sweet. So this is the basic idea. This is how we move kind of up the levels a little bit. And at the application level, you're almost always worried about IP and port. And maybe sometimes you've heard of things like port forwarding or things like that. And the idea is that we have to kind of get this packet to the right program, and the port is how we do that. The IP is how we get it to the right machine, and the port number is how we get it to the right process or program. All right, that's it for now. Take care of each other. Take care of yourselves. See you guys next time. Bye.